Okay, here I am. Let's get going. So, last time there was a brief diversion to do some logging stuff. Hi, Diana. I did figure out eventually what I was doing wrong. It's pretty straightforward. All we have to do is make the decorators into sync and then get rid of the async layer. And that should hopefully resolve the issue, and we should be able to get logging that does not error out all the time. Oh, there's no turn sync decorator. Cool. Okay. So the terminal stuff doesn't quite work. That's fine. Just gonna look that up. Plain sync decorator or by a mutex, which I guess is the other thing that you can do. Standard sync mutex new drain. Or we could just make it plain, which I guess would be fine. Let's do that. Whatever. Expected one parameter. Alright, tell you what. Terminal's going to stay async. And we'll see if that helps. And if not, we'll just stick with printf, which is totally fine. Yeah, see, that looks fine. We get micro ops logged. Alright, cool. So I am at 54 instructions implemented out of, I did the math on this earlier today, 152. So we've got quite a bit more to go. The next instruction is 1. Hopefully these are mostly just different addressing modes of existing instructions, because that should be relatively straightforward to implement. I'm just gonna restructure some of these pages, split horizontally. All right. So we've got OR, indirect X. And the indirect X address mode, index indirect, is normally used in conjunction with a table of address held on 0 page. The address of the table is taken from the instruction, and the X register is added to it to give the location of the least significant byte of the target address. Okay? And then if we pull this up here, where we have, is this 0 page indexed? No, this is indirect indexed. Indirect index. This is the main register for addressing data with indexes. It has, okay, so there's indexed indirect and there's indirect index. Interesting. Okay. Hopefully, we should be able to figure this out pretty straightforward. Okay. Indexed indirect advertising. Or advertising. Index indirect or indirect indexed? Index indirect. Okay, so let's go look at our existing implementation of Aura. Did you post that you're going live on the Reddit? I posted it in a different location, and in the one on the Emudev Reddit, I posted my schedule in the existing post, and I also tweeted. I think some of the novelty is wearing off, which is completely reasonable because this is all I'm doing. Just gluing together various opcodes and things. It's not necessarily the most riveting television. It'll pick up again once there are, graphics. Okay, so we fetch the opcode, which you already do. Fetch pointer address increment PC. So that's fetch it to where? I guess to ABL. And then read from the address, add X to it. So we do fetch to, and then okay, so we read from the address, add X to the result, fetch effective address low, fetch effective address high, address. Stream suggestion, have you considered putting on background music? I have. I used to do that when I streamed before. I don't know. What do y'all think? Do you want me to put something on in the background? I can do that. I've got it all wired up. I guess you're the only one here. I'll think about that. Maybe I'll do it next time. Probably not this time, though. Okay, so fetch the address. We want to read from the address and then add X to get the new address. Alright, let's just say fetch and index, or read and index. You need to experiment with it. Yeah, exactly. I need to spend a little bit of time playing around. But if you have any other stream suggestions, absolutely let me know. Anybody who has some cool thoughts, good to me. Sound good to me. Reg names X. Okay, so we're going to read it. We're going to index it with X. I play my own background music. Okay. And then we need to fetch. But we have a fetch to, we have a fetch and update flags, but those are both relative to the program counter. And then we have a read to. All right, let's just do read and increment. And we're going to read it to, I guess we're going to read it into the address register. Wear a sexy cosplay. I mean, I'm pretty sure Twitch has rules against that kind of thing. I could be wrong, though. Oh, all reads are relative to the address register, so that should be fine. Okay, and then we just are going to do this again. And it's not actually going to be relative to anything. So that should be fine. And then this says read from effective address. The effective address is always fetched from the 0 page. 0 page boundary crossing is not handled. Yep, that makes sense. But the effective address can point across the 0 page. Surely. As long as you're not naked, I'm sure you're fine. I mean, whatever you say, I guess. Some people do seem to get away with some scandalous things. I guess that's true. Okay, and now we do the OR. And we do need to read into something. So the next thing would be to read to reg names A. And then do the actual ORing. So does this work? Do I fetch as part of the OR normally? I think I probably do, right? CPU fetch byte. So I do, which does make sense, but the problem is that we don't want to fetch a byte because we don't want to update the address in the PC. We need to read it from the other thing. What am I trying to say? The address register. So, we want to read from the effective address and do the OR in this 6th cycle. And the best way to capture that is probably going to be to take another argument or two in the aura section so that we can say where we're going to read from. And I guess we could just fetch with the address pointer. So that means we need to update fetch byte to take an argument also. And that should do it. Okay. So first let's update fetch byte. Or rather create a new opcode or a new function because I don't want to change it everywhere else. Regnum, which is the U8. And then what we're going to do is assert regnum equals regnames PCL or regnames ABL. And then we're going to do if regnum is, oh, it needs to need as U8. This Rust requires you to be explicit, as always. Regnames PCL as U8. Then we do all this junk. Otherwise, do I have some sort of like get address, get PC? I do, get AB. Look at that. Get AB. Okay, so that'll work. And then we're going to take a reg name here, which is going to be regnames ABL, and in this case it will be regnames PCL. So that's easy, and then we just have to do it here. Oops, just to close that bracket. Regnum equals regname as U8. Pass it in, and then we'll do fetch byte from regnum, and then that ought to do it, hopefully. Let me just double check that the flags get updated in the same way, which you'd think that they would, and they do. Okay, that feels like that ought to work then. I just need to make sure that I actually put the right opcode in here, which I super didn't. And now let's try it and see what happens. Oh look, nothing builds. Okay, I definitely didn't like create a bunch of these things, so that's sensible. Reg names, yes, okay. This ought to be fine. Function takes one parameter, but 0 parameters were supplied. Read and increment reg names, and then read and increment. So read and increment doesn't need to take one. Read and index does. I didn't implement those. Read to. It's right here. We've got read and update flags. Alright, so this is going to be read and increment, which we decided didn't take a register name, but, so that's what we're going to do. I don't think I have anything about like incrementing the address bus at all. Where would that be? If get PC, get AB. Okay, so let's check out step PC because I definitely did implement this. And we'll just copy this exact same thing right here. Whoops. Sorry, my phone's ringing. It's very distracting. Okay, and that ought to do it. Again, I should really extract that out and do a better function, but whatever, it's fine. And then the other one that needs implementing is read and index. So we'll just go ahead and do that. Oop. Read and index. Oh, so yeah, this is obviously wrong. Where am I reading it to? I'm reading it to the address buffer, actually. Right, so underscore self dot regs dot abl is going to be that. Oh, but we can't do it that way, so we got to do let val equal, and we increment it. Oh no, we're going to fetch the IDL, huh? Because, geez, this is a complex setup. It doesn't really match my internal mapping of how this was going to work. That's okay. Read from the address, add X to it. Address pointer. So you fetch pointer address, increment PC. You read from the pointer address. You add X to it. What does this mean? Read from the address, add X to it. That's a pretty bad description. Is the one in here better? Address of the table is taken from the instruction. The X register is added to it to give the location of the least significant byte of the target address. Okay, so I think I was making this more complicated than it needed to be, actually, because the description was not super great. Let's see here. So what we are actually going to do, so we're going to fetch that. Then we're going to add X to that value. Then we read, then we read, then we read again. So what we're actually going to do here is we're going to fetch this to the input data latch, which is basically just our temporary register. I'm not sure if it actually corresponds to the real input data latch, but whatever. And then we're going to do an index instruction, index with, which is going to just straight up add it to the IDL. And then we're going to have read and increment IDL. This will always be, it says something about the effective address is always fetched from the 0 page. The 0 page boundary crossing is not handled, which I guess probably means it would wrap. 0 page wraparound, right? So that makes that easy also. You just have to do a wrapping add. And then we're going to read and increment from the IDL address. We're going to read it to the address bus low. And then again, reg names IDL, reg names ABH. And then we'll read from that. We will then do this bit. All right, so that's 1, 2, 3, 4, 5, 6 instructions. Everything lines up. Okay. So let's fix this now. Read and increment is going to take 2 registers, even though probably it will always be the same, but that's okay. And then index with is going to only take 1 register. we're going to stick with OR A taking the extra one. So read an increment, you're going to take so I'm going to switch these because I prefer the other order. ABL, ABH, IDL, IDL. Alright, and then we have to reg from reg. Let to reg num, to reg as U8, S2 from G, to reg num from reg num. Okay, and so now what we're going to do here is, what did I call it? Fetch byte from. Okay, so it says in here the effective address is always fetched from 0 page, which I guess would mean that these would wrap as well. Like this edition definitely wraps. The question is, does the +1 wrap also? And I guess it does, which is sort of interesting. Okay, so what we want to do is we're going to fetch CPU dot fetch byte from, and it's going to read from the address in the IDL. So that's the from reg num. And then we're going to assign it to CPU.get reg by number, which is the to reg num, is equal to the value. We're not going to update any flags. And then does fetch byte from increment? It does. And it does the increment as a 2-byte increment, which it should. Oh, I'm also saying that it can only be either the PCL or the ABL. So I should probably change that as well. Else if reg num equals reg names PCL as U8. Yeah, this wine's pretty good. It's a Chateau Saint Michel Cabernet Sauvignon, local Washington wine. Washington has good wine. I mean, I know I grew up in California, and so I should be all about the California wines, but nah. Again, I should really write myself some sort of like increment 2-byte register thing. That's okay. PC, A, B, G. And then else, we're just going to do result equals self dot get byte, self dot get reg by number, reg num, dereference that. Oh, okay, no, let reg equal self get reg by number, reg num. And then in here, we're going to dereference. And then we're going to do star reg dot is equal to star reg, or just reg dot wrapping, add 1. So that way 8-bit registers will wrap correctly. And when we go in here and we fetch the byte from the IDL and we update. Okay, so that should all be good. We already changed the aura. So now all we should need to do is the index width, which is going to be CPU.regs.idl equals CPU, oh, well, I guess it's a plus equals. No, it's a wrapping add. So we got to do CPU.regs.idl.wrapping add. And then we delete the rest of this junk here, close that up, and that should be all that we need. Okay, let's try this again. ABL doesn't exist because the address bus, for some reason, I did not make a register. I don't know why I did it that way. CPU.regs.abl. APH? What are you yelling at me for? Oh, it's self dot. Okay. 860. Just get rid of regs and that should be good. Expected U16, found U8. Oh, I can just cast that. IDL again, not a register. Cast it. Use the semicolon. Borrowing twice. Have to just dereference it because it's a copy, so it should be fine. Cannot borrow self as mutable. Mutable borrow later used here. Oh, well, yeah, okay. This is very annoying. Fine, we'll just do it twice. Who cares? Regval equals that. Get rid of that guy. Look that junk up, and then we'll have to just look it up again. Get reg by number, reg num. Sure, it'll be optimized away. That is a legitimate example of fighting with the borrow checker. It would have been fine because everything's all copy, but couldn't convince it. Invalid register number because I'm not passing the register numbers down correctly anymore because I added a bunch of opcodes. So we got to do that. We got read to. Oops, this is our 2 section. Read to. We have read and increment. Have to pass that one. And then index width is new. Pass that along. And then for A now takes a register name. Okay, and then I need to do these again. Which actually I don't know why I did all these. Only some of them should be necessary. But anyway, this one is. Oop. Card2 equals reg name as U8. Alright. Happy now? Invalid instruction 33. Okay, great. So let's see if this worked now. Look at our trace. Where are we anyway? CE22. I suppose is where we are. So let's go up here. CE. Uh-oh. Well, that's wrong, obviously. So that's in the middle of something. So let's see. I don't understand what happened here. So let's go back to that point. CE22 is not a thing. CE21 is. Okay, so we were chewing through this, and then somehow we got instruction 1 at CE20, which that doesn't seem right either. 1E is, so that's AD, fetch, 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 read to A, fetch and decode. Alright, so I somehow broke load A, I guess, and it's not bumping the register in the way that it's supposed to. So, what happened here exactly? If we look at load A, that's a load A immediate, I think. Right? Where was I? Oh no, it was an absolute because it had multiple addresses. It's right here. Okay. So load A absolute, which is right here. Fetch to and read to. So what did I change about fetch to? Well, it calls fetch byte. And fetch byte seems like it should be the same. I didn't change it. And then it calls read to, which calls read byte. Have I written an NES game or done ROM hacking before trying to write an emulator? No, I haven't, but I am familiar generally with like assembly language and emulation concepts. I've just never really played that much with the NES at that level. The origin of this is that I was challenged to write an NES emulator that could run Super Mario Bros. 3 in less than 2 weeks by some rando on the internet who may or may not be lurking. And I decided that that sounded like fun. So here we are. I'm suddenly having some sort of problem though. So what's happening exactly? Decoded the instruction. Read to, fetch to. We executed fetch to. And the PC has already been incremented. And then we execute read to, and then we fetch and decode. This doesn't seem like it could ever have worked. What did I change about read to? Huh. I should have committed before I started the stream. Just read to. Oh, read to didn't used to take an argument, so that's one thing. It looks like. Or no, it must have, because otherwise what's the 2? This is a bad way to debug. Don't do this, children. I don't know what children I think I'm talking to exactly, but okay, so this was the shift and rotate stuff that I did earlier. Did I just delete that for no good reason? Okay, well, that was dumb. Cool, I'm working on an NROM game myself. Well, if you have something put together, you can send me a link or something, and maybe I'll use it as a test game. I'm planning to start with Donkey Kong because I guess it like doesn't scroll, and it's NROM, so it should be really easy to get working. But it would be really cool to try some homebrew stuff that other people have put together. All right, so let's just fix this. I don't know why I did it that way. What's going on here with LDA abs? absolute addressing is right here, and it's 4 cycles, which is fetch, fetch, do the thing, fetch. So yeah, I don't understand what I thought I was doing there. Welcome everybody, by the way. I noticed we're up to 20 whole viewers, which is a lot for my stream, and I appreciate you stopping by. As I just mentioned a few minutes ago, the origin of this is that I was challenged to write an NES emulator in less than 2 weeks that could run Super Mario Bros. 3. And I decided that that sounded like fun, so here we are. C60F. I wish I was this Asperger's at programming. Thanks, I guess. C60F. I've been doing this a while. How many hours a day are you popping into this? Only like an hour to 2 hours every weeknight, but then I did 8 hours on the weekend. My hope, which is probably sort of unrealistic, is to... oh, hey, that's actually correct. Awesome. My hope, which is probably unrealistic, is to finish the CPU before the weekend and start on the PPU over the weekend, because I think the PPU is going to take a little while of chewing on to like really get it. Hopefully, I mean, I've basically implemented every instruction at this point, with maybe a couple of exceptions, and then once I've implemented every addressing mode, hopefully that'll be relatively like the end of it. Everything else after that will just be remixes of previous stuff. So let's look at STX. Yeah. So the only difference between absolute and 0 page is that it only fetches once. And so it's faster. So we can just say 0 page. Does read2 update flags? Because it should. Nope. Does load A update flags? Yup. So that's not right. How did I get this good at programming? Like I said, I've been doing it a while. I learned to program, I don't know, I was probably like 13 or so. I got a book from a library because I wanted to make video games. That's not how my life went after that point, but you know, that happens. Where else do I call read2? Documentation to Code Simulator 2019. I mean, yeah, that's all emulation really is. So yeah, I've been started when I was probably 13. I'm 28 now, so that's 15 years. I've been doing it professionally for a while as well. Is load X supposed to set flags? Yes. I swear I had this working previously too, so I'm confused. Anyway. Yeah, so I've been doing this for quite some time. That's how I got as good as I am. I worked for several years at a company that was working on satellites, small satellites for asteroid mining. A big part of emulation is actually writing or discovering the information for those docs. Yeah, you're absolutely right about that, but I've never contributed at that level, at least not. Well, okay, I did a little bit, although not for emulation. I was peripherally involved in one of the open source FPGA efforts. Some folks I know did way more work than I did, but I did expand support in the Ice Storm toolchain to a different family, or a different member of the existing family of FPGAs, which was pretty cool and also very easy because they did good work. That's why I've only tried really old, well-documented consoles. Yeah, exactly. Even then, though, there's a lot of documentation that's like not very good. I haven't run into it as much with, yeah, because that's wrong. I haven't run into it as much with the NES, although there have been a few things. Like I have a note here about things that where I've deviated from what the documentation says. But the N64 documentation, there is correct documentation out there, right? Like I don't want to say that there's not correct documentation available, but there's also a lot of ridiculous myths. Like there's this thing like, oh, all RAM accesses have to go through the RSP. Like, okay, technically that's true, but it's only because they put the RCP in the same die as the, or they put the RCP in the same die as the front, the North Bridge. So it's true, but it's not true in the way that people think it is. Or like, there's this other thing about the RSP being coprocessor 2 of the CPU, which is just completely incorrect. What they're actually talking about is that the vector processor of the RSP is coprocessor 2 of that CPU. So, I don't know. At some point, I would like to correct some of these misconceptions, but who's got the time? Okay, store A. So we're looking at 8B, store accumulator absolute. Should be easy. So we've got STA ZPG, I think, right? Yep. So again, exactly the same, except that we're going to fetch twice. And then that should be everything, right? GBA docs are all right, not as good as the NES ones. Yeah, I mean, it hasn't been around as long. Also, I bet that there are pretty good... Nissan supports weird stuff like OAM RAM decay. Yeah, I thought about that. I was reading about the OAM the other day. It's some sort of very short-lived dynamic RAM. Seems very strange. I would like to get to that level, but I just don't have the level of love for the NES that would be required to do such a thing. So, okay, instruction 85 is a store accumulator. Where are you actually trying to store to? Nissan debugging is a godsend, both the graphical debugging stuff and the ASM debugging stuff. Maybe I'll have to pull it out then when I get to the parts of this that are sure to really get me. What is the address? Trendo. Okay. It's hard to tell whether I have the wrong address or if I'm accessing something illegal or what. 2401 CPU memory map is one of these. So 2401 would be in a mirror 2000, which is a PPU register. The classic something broke without actually mentioning what. Yeah, what asshole wrote that debugging message? Okay, so that's probably wrong because I don't think NES uses the PPU. So I must just have the wrong address. So if we look at my trace again, we were correct up to the 8D, which is this store. At least we think we were. Load accumulator 0. Store 7FF equals FB. So, what? Oh, okay, so I guess that's where the stack pointer is? I'm confused. FF07. Okay, so yeah, that makes sense. So we would store at the top of RAM and then load 0. Oh, the store should wrap around? Is that what we're saying? No, that doesn't make sense. I should start debugging. I should start printing out my register values, I guess. Let's see which ones we've got here. We got A, X, Y, P, SP. And then I guess PPU and psych are like the cycle counters. So when we log this, do A, X, Y, S, and P. Get PC, self.regs.a, self.regs.x, self.regs.y, self.regs.s, self.regs.p. Okay. Might as well print everything NES has in that same format. Yeah. That would be the sensible thing to do, I suppose. Alright, so where are we here? Okay, so our A is wrong. Because we didn't load our accumulator correctly, I guess. Where's 8D? EA, D0, 4C, EA, A9. Wait, where's the A9? Oh, I'm looking at totally the wrong spot. Thought I got further than this before. Yeah, okay. When you write. Printing everything NES has in its correct format is probably a good idea. So this is like way at the beginning of the log. I broke something that previously worked. So this is a store 0 page or immediate that I broke? 85 is 0 page. Oh, I have it in here twice. Yeah, that'll do it. What I was implementing was absolute, I think. Yeah. Okay. I'm using a formatter that XU8 looks odd to me. Oh, the sharp just puts a 0x on the front of it for hex digits. Alright, so now I need to get the correct opcode, which is of course 8D, and then that ought to do it. Let's get back to where we were, A. CFD9, that looks a lot better. Panicked at invalid instruction A1. If a whiteboarding interviewer asked, how would you build an NES emulator, would you pretend to think about it for 5 seconds, then bust out 5,000 lines? I mean, this is going to go on my resume, I'll tell you that. Also, I would never try to write 5,000 lines of code in a whiteboard interview. No, I'm not using Rust format at the moment. For some reason, when I first learned Rust, I thought you needed a space after the variable name, so I did all of my variables as like XU8. I try to correct myself to X:(U8 now that I know better, but I just built the muscle memory, so I screw it up all the time. Whiteboard interviews in general, like, really suck. You don't need me to tell you that, though. It's like a meme at this point in the programming community. CFD9. Okay, so then we tried to munch A8, which is an index load accumulator. Or A1, rather. Didn't I just do this? Load accumulator. High-level answers to a complex question. Whiteboard interviews are where they're like, oh, could you reverse a linked list for me on this whiteboard? And then you have to like actually write out the code that you would write on a whiteboard without being able to do, you know, minor useful things like, say, actually running the code. How old are you, Nick? Are you still in school? I gotta think a little bit more seriously for a moment. Writing code with a pen marker outside uni sounds horrible. I mean, it is. It was horrible in uni. It doesn't get less horrible. It gets, if anything, more horrible because the stakes are higher. Okay, so what is the difference here? It's just that it's read and update flags to A, right? That's the only difference. We just don't do the OR. Okay, invalid instruction 81 at address. Wow, there's a lot of extra debugging floating around in here. D1008. D1009. Okay. Hey, that looks correct also. So this is just the store indirect X. And it's store A, right? Yep. It's 81, or, yeah, 81. I'm 21, currently doing third-year subjects, only to systems engineering. Started working full-time this month. Oh, hey, congratulations. Web backend stuff, lots of legacy microservices. It's all right for a first job. Hey, man, anything is all right for a first job, if you ask me. The trick is getting in the door. Okay, so we're going to do exactly the same song and dance here. Except that instead of reading, we're going to write. Seem reasonable? '81, 6 cycles. Yep, seems good to me. Let's do it. Uh-oh. I made a boo-boo at some point here. Or maybe not, because I did say that sometimes it just writes to 0 for no good reason. The debugging in NES test, or not the debugging, but like the error reporting doesn't seem to be super good. So we fetched 81. And, okay. Fetch to IDL at A should give us 80. Index with X gives us 80 plus whatever was in X, which looks like it was a 0. Getting register number 7. Reading from DB is EX. Or no, it's not reading from there. It's reading from whatever's in the address bus. And then you're supposed to write to, I guess this is turning out to be a write to 0. Which I'm not sure if that's right or wrong, honestly. 80 plus X and X is 0. It seems like you should be storing to 80. Right? Or no, it's storing to whatever the value at 80 is. And I don't know that we ever actually set that value. Man, I really don't like the uncertainty of whether this is actually a problem. How do I look when I go into this compared to them? So I've got go to instruction 81. So when we first execute it, we get A is A, X is 0, Y is 69, P is wrong. So my P is 6 instead of 27, which I guess is what it's supposed to be. And S is FB. But we're not doing anything conditional. This isn't on your GitHub yet, right? No, it's not. I probably should push it, actually. Thanks for reminding me to do that. I'll do that at the end of this stream. Getting register 9, getting register 9, getting register 10, getting register 9, 9, 11. This is very annoying. I'm gonna go through and log everything and then just say add a bunch of logging, and then if I still am doing fine, I'm just gonna decide that it's not actually a problem. Fetching from wait a minute. No, that seems right. And so then index with indexing IDL x with x sharp x self, or no, not self, CPU.idl, CPU.regs.x. That URL thing looks cool. Ha! You creepin'. Yeah, I wrote just a straightforward implementation of Early's 1970 paper on early parsing, or recognizing, really. I just, my intention is to take that, rewrite it in a more modern style, and then implement some of the improvements that have been done to early parsing over the years, and then eventually slide into some data-dependent grammar parsing, because I think that is cool. Okay, so what's going on here? Indexing IDL equals 80 with x equals 0. So we get 80. And then we do read and increment. I'm lately really into programs that write programs, like anything that we can use computers to make us not have to write quite so much software, especially since it's likely to be less buggy anyway. That's my current interest when I'm not implementing challenges for internet randos. Okay, so read and increment, we're going to do reading from address and then it's self regs IDL. It's not a regs, and it's not a self. Size approval, yes, that's exactly what I win. Nerd cred. I don't think anything could let me win size approval, but I will get nerd cred. The historical stakes for an EmuDev bet are pizza, but I am a grown-ass man and can order my own pizza. So, yeah, it's really not a big deal. Nick, did you ever run NES tests for your emulator? Your NES emulator? Yeah, it was the first thing I did. Did you, so in the documentation, which is over here, what's supposed to happen when you fail is that it's supposed to write to two and to 3. Which it says somewhere else. But according to Psi, it also writes to address 0. And I did find that it was, in fact, writing to address 0. I just printed the same thing as the log file did and git diffed. Alright, I'm just going to say that it's fine. I think it is fine. Address not implemented AC00, so maybe it's not fine. 81 at D01A. Store FFX, indexing IDL FF with X0, should be 7, reading from address FF, reading from address 00. So yeah, that's correct. I don't know why I ended up with AC00. Load A, store to 80X, 83. Probably something to do with this in here. I don't know what's going on, honestly. I've got some sort of problem with my store, I guess. Okay, so let's here's what we're going to do. Alright. If self.ram 0x00 is equal to 0. Hard coding a print for that specific address. Yeah, so that's what I was going to do, something similar to that. But instead I was just going to print out the RAM if I fail. Oh, come on. Why can't I have const generics? Why? Why? Okay. Yeah, let's just do what you said. RAM address is now yeah, I know. Laugh it up, but I mean, you could probably do iter collect vec, which isn't as nice, but would work, I think. I thought it was already a vec. I guess it's not. Yeah, you're right. I could do that. This should probably go after. Wait a minute, though. So this is a store A to FFX. It will definitely write to address 0. Right? Or maybe read from it. Okay, yeah, there's no reason that the store should actually write to address 0. So what's happening here? It's this first one that's the problem. I need to close some of these windows so I can put both things up at once. Alright, so STA indirect is right here. And what it does is we fetch to IDL. And what we're going to do, fetch address to IDL, CPU.idl. And then we do index width, which I already changed to do that. And then we do read and increment, which says reading from AB now, and should probably include IDL now. .idl. Go. Gonna yell at me, huh? Oh, no, you didn't. Okay. Oh, okay. Hang on. I think I probably understand what's going on now. Indirect addressing. Where are you here? Index indirect for write instructions. Yeah, okay. So, fetch pointer address increment PC. We do that. But what we need to do next is read from the address. No, we do that already. Hang on. That's, yeah, okay. Well, we already got confused by this. So then we index it with X. Read an increment, and then write A. So that makes me think that, yeah, actually it totally will store to that address because, well, no, okay, because we started. Okay, so we read the value FF into the index register. Then we add X. X is currently 0, so we stick with FF. Then we read 0 and 1 into the address register. And so whatever is at 1 is what we will then write to that address. And because we are writing to that address earlier, then everything screws up. So that's why I think that this is the one that is wrong. And so in this case, what we're doing is we decode. Okay, so starting from here and going down. We're going to fetch to IDL from PC DA, which should set IDL to 80. That's correct. Then we should add X, which this agrees with us is supposed to be 0 because we just did a load X immediate. So we're going to index IDL 80 with X 0. Right? Then that means that we're going to read from address 0, and we got ABL 700. And then IDL is 80, and then we read from this. Now AB is 0. Is that what it's supposed to be? Because I actually have no idea. Cool. Cool, 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 cool. This is a real pain in the butt. When else would we be storing something to that address, which is 80? Alright, so what stores to memory? Got store accumulator, store accumulator to 1. Blah, blah, blah. Blah, blah, blah. Store accumulator 1 equals 80. Maybe that's what I was supposed to be writing there. That is a 0 page, I think, store. 85. Yeah. So the 0 page store would actually store to bit 1. So that's not it. I don't know what this equals 80 is about. Sorry, folks. I know this is super uninteresting television, but I'm gotta figure out what's going on here. Appreciate y'all stopping by. Sorry it's not making a little bit more progress, but you know, this is the reality, honestly, of software. Nothing ever works. Everything's always broken. Everything's always terrible. And then you fix it, and then you feel good, at least for a little while, until the next thing breaks. Okay, so a 0 page store that would set this would be an 8580. And in fact, there is one of those at CFA9, but it specifically says it stores 0 because that's what the accumulator is. And then that's the only one. So we do definitely set it to 0, 0 at this point. Do we ever store anything else to 85? It doesn't look like it because we run into this right at the beginning of FB. What value is 80 at that point? It looks like it's 0. It looks like, I mean, it is 0. That's what it is in my emulator. And it looks like it's supposed to be 0, as far as I can tell. Even though that seems a little bit weird. And there don't seem to be any other stores to 80. Stepping through it in Meeson. Yeah, that's a good idea. I don't even have Meeson installed. Right, and then x is 0, and 80, and then this says equals 200 equals 5a. I don't know what that's about. When it says equals 200, am I supposed to come up with the 200? I don't see how I could, because that's 80, and that's 81. And I don't see any further writes to 81 either. Yeah, stepping through it in Meeson is a good idea. Just download Meeson. Oops. Sure. Let's move over here. Okay. Where is this? Red. Okay. And then nest test. Oh, it's got sound and everything. Whoa, that's freaky. So, how does one debug things in Meeson? Debugger. Whoa. That's a lot. So, we want to look at where? Starting from basically right here, CFA. So here's the RTS and here's the JSR. So the JSR goes to CFA2. So that's probably where we should start. Not sure how to set a breakpoint there. It doesn't show up in this list. It says unidentified block. Toggle breakpoint. Add to watch. How do I add a breakpoint here? I want to break on. Oh, that's a scan line. I don't want to break on a scan line. Break in. No. I want to break specifically at a location. How come I can't do that? Well, maybe if I run the test first. What button is start exactly? Oh, it's pause because I'm in the emulator, I guess. There we go. Which button is enter? Oops. Nope. Let's change the input options. Setup. Okay. Conflicting key bindings, whatever. Okay, that's cool. It succeeds, but I still can't see the place to set the breakpoint. What am I supposed to do here exactly? Alright, everything is code now because I said so. CF something is what I was looking for. CFA2. Alright, so let's scroll on down. CFA2. Okay, there we go. Toggle breakpoint. Alright, so if I hit enter again, we should actually hit it. Okay, cool. And now we want to see RAM. So where's RAM at? You could try to reset it, then set the PC in the debugger. I mean, this seems to be working. I wish I could see RAM. There must be a way to see RAM. Where is RAM? Show. No. Edit, subroutine, edit in memory viewer. I don't want to edit it, I just want to look at it. So hopefully this will work. Memory tools, maybe. Alright, so let's step, step, step. Work RAM, is that what we want to see? I guess it is, right? And then 80 is right here. Okay, now we can at least see what's going on. Okay, so we should store to RAM location 1 and FF. Don't see it though. I was looking at the wrong thing. Okay, so 80 is 0002. So we are supposed to be looking at 02. That's the problem. I guess. Yeah, so it's this thing that's going on. It's because you store a 02. But I don't know why this shows a 0. That's just straight up wrong. But that's the problem, is that it's supposed to set that address to 2, and it appears not to be doing that. So if we look at an STA0 page, what are we actually doing in that case? fetch to ABL, write A. Let's go to write, and we'll just print what we're going to write and to where. Writing value to address val CPU.getAB and go. Okay, and that's at CFAD is when we do that right, so it's quite a while back actually. So here we go, CFAD, executing micro op write A is 2, writing value 2 to address 781, which is not correct. The 7 is extra. Okay, so where's the previous one? 7FA9 is probably also wrong. 7FA9. Writing value 0 to 780. Is that mirrored? No. I thought I had set it so that it would clear A when it's written to, but apparently that's not happening. So that's probably what's going on. STA ZPG calls fetch 2, which fetch 2 calls fetch byte and stores to CPU get read by number. So I guess that's the problem then, is that we're not clearing AB. We should always probably just clear AB anytime we use it. So that would be all of the reads and all of the writes. CPU.abl equals 0, CPU.abh equals 0. Okay, we're just going to do that every time we use the address bus, and then that'll probably fix our problem. I think that's all the ones that use it. Alright, read to, read an increment, read and update flags, and write. And then fetch uses PC, which is fine. Yep, okay. Let's go. Show me that everything is good. Okay, we're still writing to RAM 0, but I think that's probably okay. But let's start at, what did we say we were looking at? CFAD, we don't even make it there. CF75-ish. It's not a real thing, so we definitely screwed up somewhere. CF72, CF67. Right, so CF67 is a BMI, and it's probably not supposed to branch, but it is branching. How many days do I have left? So this is, what, Wednesday? I have today and tomorrow for this week. I have something to do on Friday. And then I have the weekend. It's basically till November 1st, so however many days that is. Things were rolling along at a pretty good clip until I hit this particular issue, which is proving to be relatively sticky. So what are you branching on? Roar A. What? How could I possibly have broken Roar A? I don't understand. Seven, I guess. Yeah. 7 or 8, depending on how you count it. 8 or 9. Anywhere between 7 and 9. Okay, so let's see here. I bet I know why my flags are all wrong, and it's because I'm not... Well, maybe I don't know why my flags are all wrong, because the Yeah, so the unused flags are not affected, so that's not right. How did I break the rotate instruction? Today is not my best day. Alright, CF67 is right here, and that's what branches us off to nowhere. This is a branch equal. This is a BCC. 6A is rotate. P was 4. Now P is 85 after the rotate. Is that what it's supposed to be? No, it's supposed to be 25, apparently. And A is supposed to be 2A, not AA. And X is 55 is correct. Y is 69 is correct. Stack pointer FB is correct. Was I right up until that load A, which is at CF60? Oh, okay, yeah, I'm dumb. I get it. Well, maybe I don't get it, actually. Okay, so LDA, 55, CF60. Where's that at? 5E, 60. CF60 does fetch and update flags because it's a load direct. Am I creating an NES emulator? Yes, that's exactly what I'm doing. So an NES emulator challenge was issued to me to complete an NES emulator capable of running Super Mario Bros. 3 in 2 weeks or less. I have until November 1st, basically. And so that's what I'm working on. There are no actual stakes to this challenge, but it seemed like a fun thing to do, so I'm doing it. Okay. A is 55. And then after the rotate, it becomes 2A. I don't understand. Let's pull up calculator real quick. Wow, so cool. Thank you. Yeah, it's pretty fun. I'm enjoying myself, except for when things don't work. So if I right shift 1, I get 2A. But because this bit was set, does it rotate into the carry flag instead of through the place I thought it rotated to? That could be why. Rotate was the last thing I implemented before I went to bed, so it's not that surprising that it's wrong. Set to contents of old bit 0. Bit 7 is filled with the current value of the carry flag. Okay, so yeah, that's what's going on. So this has been broken for a long time. I wonder why it was getting away with it before. Yeah, this is obviously wrong. Okay, so we're going to left shift that by 1, actually. I deleted the wrong thing. Are you a programmer? Sixaverica? I suspect your name was not meant to be pronounced. Okay, so we are going to shift it by 1, and then we're going to OR it with cpu.regs.p is for status, 0x1, left shifted by 7. Okay, so this is the carry flag here. We're going to left shift it by 7 to put it in the top, and then later on we set the flag based on whether it was set before or not. Yes, but I know almost nothing about electrical and embedded systems. They're pretty interesting. They're a lot of fun. Are you more of like a web person, or? Okay, now I gotta fix rotate left, which is is doing exactly the same problem. Bit 0 is filled with the current value of the carry flag this time, so this is just going to be CPU regs P and 0x01. Doesn't need a shift. And then that's set based on whether the old top bit was set. CFC5, huh? Let's see. Is that around where I was looking at before? CFC5. No, so we're on CFC3 right here. Store A 0 equals 0, huh? Was working as a full stack dev for a year. Now I'm in a startup focused on creating checkout free systems for stores. Huh, that's cool. I love checkout free systems at stores. Having experienced it exactly once at the creepy Amazon store. Alright, so let's see. Low-level things are more interesting. I have often felt that way. But I don't think it's necessarily a universal feeling. Okay, so this is a completely valid store to address 0, right? Because we load A with 4, and then we store it to 0. Like, there's no other way to interpret this. 85 is a 0 page, right? To address 0. So I just need to turn off the don't write to address 0 thing. Gosh darn it. Here we go. I mean, if you're interested in EmuDev, for how long have I been working on this? I started on Saturday. So this is day 5. Although, obviously, weekend days count a little bit more than non-weekend days. Valid instruction 84, huh? That's an STY at D1DA. Is that where we're supposed to be? F7C2. Wow, okay, yeah, this doesn't look right. Alright, so D055. If you're interested in emulation development, I mean, there's a really great Discord community. That's where I got this challenge from. You're absolutely welcome to join us anytime. Go to our EmuDev on Reddit and just click on the chat thing. We'd be happy to have you. F7C2 is BPL, which I apparently also broke somehow. Let's see what's going on here. This looks correct. And we are at A is 5D instead of FF, so that's not right. Where can I find the Discord link? I'm the big NES games fan, by the way. Yeah, let me just pull this up real quick. EmuDev. And then the Discord link is right here. So, there you go. I'll drop it in chat. Okay, so it looks like the aura is going wrong, which is at address D053, which should be one before here, right here. And when we go into that, we're 88. We're supposed to be aura-ing with AA. Reading from address 80. Reading from address 81. What is going on here? Fetch address C0. Oh no, that's the 20. I'm already past where I wanted to be. Yeah, so this is obviously wrong. What am I ORing against? Oh boy, I'm really on the struggle bus today. I'm having a hard time. Once I figure this out, maybe I'll... No, I don't want to do that. I'm trying to finish the CPU by the weekend. I have to get a lot more done. Let's see here. So this is an OR indirect, right? That's what I thought. OR indirect X. Going into it, we have X equals 0 there, and we have X equals 0 here, so that's correct. So then what we do is execute the fetch to IDL. We fetch address 80 to IDL. That makes sense. That's correct. Index width, you get 80, which is correct. Read and increment from address 80. AB is 0. Read and increment from address 81. AB is 20. Or not 20, 200. So when we read again in Aura, we need to print out what we're reading out. I'm driving the struggle bus. Yes, indeed. Fetch byte from regnum. ORing A sharp X with loaded value sharp X CPU regs A loaded. I mean, I suspect I screwed up a store earlier rather than the actual problem being my OR implementation, but I just want to double check it. Did I make it worse? What? Oh, I know what. Okay, there we go. Okay, opcode 1 is right here. Still end up with 5D with loaded value 59, which is obviously wrong. So what was the last store to that location? This is me. It's supposed to be AA. Here's the store, which is D049. This is an immediate load, so that certainly should have worked. This is a store absolute, which is 8D. So STA abs, 8D. Fetch right. So let's find that, D049. Just before we take this brief detour off to F land. 49, okay. Fetch. A becomes AA, like it should. Writing value AA to address 200. Okay. So that looks like it was correct. So what happens between there and there? FF to 1. That's weird. Well, I'm going to change this from 0 to 200, and then I can kind of track it a little bit better. I'm also going to indent the writing a little bit so I can find them. What? Did I fix it at some point? What just happened? I'm so confused now. Does this just work now? That's not how things are supposed to go. F7C2 is right here. Okay, yeah, so this is the same thing, is that we're branching off into somewhere bananas. F7CB, apparently, and dying there. We're doing that because this aura is wrong. So that's 53. A is 55. It still says that 200 is A. It still says that 200 is A. It says the address bus is 200, but then it loads 59. What? This is going to be such a dumb problem when I figure out what it is. Like, I absolutely know it's going to be the stupidest thing. Register hash name. Reading from address for aura. CPU.regs, or no, CPU.get AB. Go. Everyone, thank you so much for stopping by. I really appreciate it. I'm sorry that I'm just kind of slamming my head against this stupid problem for so long, but I appreciate you showing up and sticking with me, and honestly, this is a lot of how the sausage is actually made, so I appreciate you coming by. Calling Aura with register ABL. Reading from address 0? It literally says that it's 200. So, oh my goodness. Hang on. I think maybe I figured it out. So if you look at what happens when you do Aura indirect, you do read and increment. And if we look at read and increment, I was blowing away my address. Oh man, that's so dumb. That's very upsettingly stupid. Okay. What is the right way to fix this problem? What I basically wanted to do was to clear AH, address bus H, when I wrote to address bus L. That was my original intention. But because of how I'm handling that currently, it's challenging. I could change a bunch of stuff, which I don't really want to do, especially at this point. I mean, I could hard code it in a couple of different places. That would be sort of sucky. I guess let's just do it this way. If CPU.idl, no, that's not right. If toReg num is equal to reg names ABL as U8, clear the top bit. Alright, and we'll just replace all of these with this, except it's not always going to be toReg num. Sometimes it will just be reg num. And all those things where I added a clear, which is basically going to be at any of the read calls and at the write call. There's one there, one there. Then there's one here. And then in write, actually I guess write doesn't even need it because write doesn't modify the address bus. But these can. Okay, so hopefully now things will start to make a little bit more sense because we won't necessarily be writing to 0 every single time. Address not implemented ACOO. Okay, I hit this. Oh, hello, buddy. All right, cat break. Everyone check out my cat. He's beautiful. He's a good boy. Look at the people. He's a good kitty. Okay, back to work. What happened? Hi, kitty. Yes, Diana says hi. Hello. Alright. Where am I? What's happening? Who are you people? How did you get into my house? D01A. Right there. Store. Let's see, are we generally on track? A is 80, X is 0, Y is 69, S is FB, P is A5, not 84, but okay. Load A from 200 is supposed to be AA, but it's not. How did it get set to AA? It looks like it literally just got set to 5A. So that's weird. But it says load A, AA, and then it gets set to AA. So what's happening here? That is weird. Well, this is just wrong because that's an AA, so cool. Okay, so when we store at D1009, we should be storing a double A. There's D1009, it's got to be in here somewhere. There we go, D1009. A is AA, so that's correct. Fetching address 80 to IDL. Indexing with 0. AB is now 700. And AB is now 0. So that didn't work. Read and increment. I must have done it wrong. So this to read is ABL. And so that should have cleared the top. And then this to read is ABH, which should not have cleared anything. Oh, I'm printing my AB before I clear it. That was dumb. D1009 again. Gotta say, I'm surprised at how many people are sitting around watching me try to debug code. Happy to answer any questions anybody has, or if you're interested in what I'm doing or things I've done in the past or software or hardware or whatever, speak up, because anything's better than staring at this. Okay. Alright. So it's not correct here because the address we're reading is 0. And the address we're reading shouldn't be 0. But what should it be? When was the last time we stored to address 80? It was like a million years ago, I think. Yeah, I'm not seeing any stores to 80 for a very long time. So what happened? I know this is one of those things where as soon as I like go to bed, I'll be like, oh my god, I get it. Alright, well, we load from 80. FFX. Yeah, okay, that's it. Load 3. Here we go. So we load from 80 at CFDB. Does that seem right? CFDB. Load from 80 into the accumulator, which becomes 5D. No, it becomes 0, which it's not supposed to. It's supposed to be 5A. So I must be writing to address address 80 is 81 rather is what's supposed to be pointing at 200, and we're not changing it ever. So let's just add it to this print statement real quick. Or 81. Change the address so I don't confuse myself, because I totally would. Boy, you're just making yourself right at home, huh, bud? Usually the cat hates when I'm talking to people that can't see, but for some reason he's just chilling today. Has 81 ever not been 0? Assert self.ram 81 is equal to 0. Alright, so if it's ever set to anything else, which it should be, then we should hit an assert. But we don't, even though we used to. Okay. STA 80 x equals 0, x equals 2, x equals 3. Maybe it's 80, not 81. I thought it was 81. Oh no, it would be 80, wouldn't it? Because right, okay, so we want to write something to address 80. Hi, Cat. How you doing? I am really not tracking at the moment. Alright, let's see if this just hits an assert. Nope. Ugh. Okay. I'm screwing something up, obviously. 8D is store absolute, which I don't think I will see. If we start at the top, let's see here, 8D 80 is like way down here. Okay? What are the other address stores here? So reference STA. 0 page is 85, which would just be 8580 or 8581. Which we do, but we only store a 0 there. 8581, we store a 2. So how come that doesn't work? STA 0 page. I didn't like screw up and double implement this or something, did I? Doesn't look like it. Okay, that's good. We do fetch 2. Okay, fetch 2. Reg names. And of course, we're not clearing it, even though we absolutely need to be. Sweet. Cool, cool, cool. All right, so read. We probably just need to add this to both of the fetches, or all of the fetches, really. But I think only 2 of them are like real. Okay, so there just has to be a better way to do this, but I want to get it working before I start thinking about being extremely clever. Okay. Fetch and update flags. All right. That should go right there. And then fetch and decode, if I remember correctly, does like a totally different thing. Oh, buddy, it's a good kitty. Yeah, so none of those only go to the PC, so it should be fine. So now we should hit that assert. Nope, didn't hit that assert. Cool. Oh, because it's 81, not 80. So that's fine. 81. Now we should hit that assert. Please and thank you. Yay! Okay, so we do set that. It's good. If we run it, invalid instruction 84 at F7CB. F7CB is not a real address. D055 is. D055 is JSR. C2. And then we branch off into Banana Land, so that's still wrong. Where's the aura? Oh. Here's aura. A is 55. RAM address 200 is still AA. Reading from address 20, 200, but then we end up with a loaded value of 0. Okay, so we got the address right at least. Making progress. Calling aura with register this. Reading from address 200. Register ABL. When we go to call fetch byte from, this is supposed to be ABL. Darn it. There we go. Okay, invalid instruction 21 at D065. That sounds believable to me. Yep, there we are. Indirect, index, and. How long have I been doing this thing that I've been doing? 2 hours. Alright. I'm going to keep going until 9 o'clock. I'm going to just implement as much as I can between now and then. Because I've got a lot to do, and I don't want to waste... I don't want to waste the days, for lack of a better term. Okay, so hopefully, again, we can just copy and paste and make it an and the only difference will be that this is an and, except that we need to do this jump here as well as there. Probably have to do it a bunch of other places too, we'll see. I did it. Yes, I did, eventually. But hey, I'll take that win. It's important to take wins. Even when it feels like maybe it shouldn't have taken you that long. Who's to say from should? Should is dumb. "21 people talking. And yet or 21 people watching, rather. Yet nobody's talking. Oh well, that's fine. If you don't want to talk, absolutely don't have to. I would be interested in knowing sort of who you are, how you came to find the stream, what your interest is, if you feel like sharing. But if you don't, you know, that's totally fine. I appreciate you showing up to watch. It's considerably more than I could ask for anyway. Alright, D07C. Are you real? You are real. Okay, that's exclusive OR. Easy peasy. EOR. Reg name. Reg num. Fetch byte from reg num. Go down to the bottom. Add EOR to this set. EOR immediate. It's up here. Copy the OR indirect. Drop it right below. Change this to EOR indirect. Hey, how's it going? It's going well. Now that I've figured it out, what my problem was, I am back in high spirits and trying to just crank through as many of these as I can, as quickly as I can. Indirect X. The problem that I was having turned out to be silly, as I expected it to be. Wicked awesome, thanks! Yeah, it feels good. Found fun item. 655. Oh yeah, okay. Reg names, PCL. Yeah, it feels good. I mean, I still have a long way to go. My goal is to implement the whole CPU before the weekend so that I can focus on graphics after that point. But I don't know how realistic that is, but I'm going to do it my best. When I started this stream, I had implemented 54 out of 152 combinations of opcode and address mode. Don't know what I'm at now, but we can check at the end, I guess. Also, my cat's sitting on my lap. That makes everything better. Still trying to learn how to do more than just put a single sprite on the stream. Or on the screen. Slip of the tongue. Fetch bite from... Cats are good content. It's true. He a good boy. There we go. Come on. There we go. Kitty. He's a good cat. Very cuddly, very needy cats that I have for whatever reason. The fluffy boy. Actually, the fluffy boy is the other one. PCL. This one is only mildly fluffy. So, Silverblaze, thanks again for coming by. Are you a student? Might want to angle the camera a bit down. Thanks, Di. That's not better. Come on. How's that? Okay. So yeah, Silverblaze, are you a student? Are you studying to be a programmer? Are you already one? What's your story? If you feel comfortable sharing, of course. I didn't. I was homeschooled. Okay, that's cool. Are you interested in software engineering as a profession and whatnot? I taught myself pretty much everything about programming computers. That's awesome. I really love how accessible information about computers and stuff is. Like, it's great that that is a possible thing to do. Does SMB3 boot yet? No, sigh. Man, I don't know where you were. You missed an excellent chance to totally dab on me. I had like a dumb problem for like an hour and a half. Whoa, what? Okay, I guess this needs another one. I was playing Paladins. What's Paladins? I'm currently working on a game using GameMaker Studio with the limits of the NES at the forefront of the development. It's like Overwatch, but F2P. Would you believe I thought Overwatch was F2P? That's really cool, Silverblaze. What kind of game are you making? What genre? What's the vision? It's an adventure platformer similar to Celeste. I loved Celeste. Celeste was great. But with cats and magic. I also love cats and magic, so sounds like you're doing something right. Assuming, as I obviously am, that I am your target. PCL. Absolutely. Reg names A. Because that's comp, not CPY or CPX. Okay, go. Bad problems. Oh, yeah, fair. I must not. What was the dumb problem you were hunting down? I must have had how doubtable it is. Does the game have a name? Excellent question. It's honestly not even clear what the ultimate problem was. First, I was assuming for some reason that writing to the low address register cleared the upper address register, even though I never actually programmed that in. And then I screwed up fixing that like 6 times. Then I was always clearing the address bus to 0 no matter what. It was a mess. I should have gone to bed, honestly, but I don't have a lot of time, and I wanted to like wash the stain of failure out of my mouth, to be perfectly honest. I see. Oh, yes, of course. The game's name is Micro Kitty. That's cool. It's actually got a page on itch.io. Oh, sweet, yeah. I forgot to write the thing. Didn't I do that? I thought I did that. Guess not. I saw that you had pulled up Misen. Yeah, I did. Honestly, didn't need to, it turned out, but all it did was like confirm whether I was being an idiot or not. And the answer, of course, was yes. Still very early in development, and I'm rebuilding the text system for the 6th time. Oh, so I will tell you all about my tendency to rewrite all my code a billion times. But you know what? I was saying this to somebody just the other day, but if I'm not building a system that I'm like going to be proud of and happy with, then what's the point? Like, I don't get paid for this. If I am going to make a thing, I want it to be a thing that I'm satisfied with, that I'm happy with. So I don't feel any particular need to refrain from rewriting stuff if I think I have a better idea. Now, that being said, in this particular challenge, that would be a bad call. The solution is to make the system correct from the get-go. I don't know how you could possibly know whether that's the solution or not, Sai, considering that that's not what you do. Can you run Battletoads yet? Arguably, I make the system correct from the get-go more than you do. I do know what a good solution is. It involves SMB3 booting. Yeah. Okay. Text systems are some of the hardest to write, in my opinion. Yeah, you know, I think I agree with that. It's one of those things that, like, seems like it ought to be simple, and then you think about it, and you're like, oh, no. I guess I can see why that would be hard. The other one for those for me is time. I'm always like, oh, I'll just whip together time, and it's like, no, you won't. Time is extremely complicated. I am 99% certain your emulator will not be playing Battletoads correctly by the end of this challenge. Yeah, that's probably true, but I bet it will be shortly thereafter. Unless I decide I'm done with the NES, which is actually pretty possible. But I feel like I have to implement Battletoads just because you're so annoying. It's simple if you don't want to do anything more than show a line of text on screen. Instruction 37. Is that right? That's a new kind of instruction. I better just double check that I didn't run off the rails. Since that doesn't seem to be a real instruction, I probably ran off the rails. D136 is an SBC. D138 is a JSR, but I don't seem to have done that. We end up at D139. We're fetching too many times. What dumb thing did I do? I also plan to start a Kickstarter for the game once I have my public demo ready. One of the stretch goals I have in mind is to support the game to an actual NES cart. Yeah, that seems to be a thing now that people do, which is really cool. I was just reading an article about that. What's going on here? Why am I double incrementing the PC only for SBC? Because I didn't change this to fetch byte from, that's why. There we go. Silly, silly. Don't forget your own custom mappers so you can make NES emulator suffer. We already discussed, or no, that wasn't you. That was somebody else who was talking about making an NROM game, I think. Maybe it was you. It's been a long night. LDY 0 page? I don't have LDY 0 page. At least it's easy. CPG. LDA. LDY. 4. LDA ZPG. Just plop your game in a cartridge that has an ARM7 TDMI in it. Who makes those, like, who's the vendor? Or is it Nintendo Silicon for the TDMI and the GBA? Like I said, at least it's easy. Same for STY, because I have STX. Pretty sure anyway. Yep. STY, ZPG, 84. Y, right Y. Don't know who makes them, probably a bunch of people. I actually have no idea what that means. So ARM7 TDMI is like a particular type of ARM core, which is the core that is used as the CPU in the Game Boy Advance. Sorry, I forget. Do you have a GBA emulator or just the DS ones? But anyway, Sai is suggesting basically that you build a GBA into an NES cart with a custom mapper solely to make emulator authors suffer. Which is a weird thing for an emulator author to do, I agree. Nope, it's A6. I had that totally wrong. Gotta get those extra cycles. Well, can't argue with that. Oh wait, yes I can. So is there a weird thing where like one of the load instructions doesn't set flags for no good reason? There was an SNES chess game that used an ARM processor to handle the AI. Really? I didn't know that. It's not that surprising, I guess. Is that why Bu has an ARM core? Or a 0 page. Or. Then again, coprocessors wasn't that uncommon on the SNES. Yes, that is true. It really blew my mind when I realized, probably far later than is reasonable, that literally those old consoles just exposed CPU pins directly onto the cartridge bus. Like, holy, okay, I mean, I guess, whatever floats your boat, buddy. So the ZPG is exactly the same as the immediate, except that you fetch first. So, right, let me just... Fetch to ABL. And then do aura with the ABL source. Rip CPU pins. It kind of reminds me of the Atari Jaguar. It's actually really interesting. Those old processes were way more tolerant to things like overvoltage in a lot of cases. Not all cases, but a lot of cases, than modern processors are. Modern processors tend to just like go to pieces if you don't have really good ESD protection on them. The sort of history of like how process nodes have evolved and their different characteristics is a lot more interesting than I thought it was before I learned some things about it. Kind of reminds me of the Atari Jaguar. They made 2 custom CPUs and had them mediated by a central 68K. Waste of R&D if you asked me. Yeah, that sounds a little bit silly. Oh, silly. Isn't it like the Saturn that has like an SH2 and an SH4 and like a bunch of other stuff in it? Modern processors aren't made by Nintendo and they're Nintendium material. I think it's really interesting that they switched away from custom processors with the GBA. Because the TDMI core is just off the shelf, right, Sai? I feel like you told me that before. Exclusive or 0 page. Easy. Both of the CPUs had a bug where using jump in main memory would cause program memory to be corrupted. Yeah, the MSP430s, which are, in other respects, one of my favorite microcontroller architectures, have this thing where, like, I don't even know how to explain it. It's a really stupid CPU bug, and it's, like, intrinsic to the core somehow, because they haven't fixed it in, like, 18 silicon revisions. And basically, like, sometimes when you jump, the target after the jump will just die. And so all jump targets in the compiler are like padded with an extra no-op. It's very weird. The compiler works around it and it's fine, but it's just like, holy cow. What? Oh, yeah, it's ADC. CPU will jump when it feels like it. I mean, hey, if you're going to teach rocks to think, you have to be willing to accept what they're going to try to tell you. This is a brief philosophical tangent, but it's really interesting to me, like, that's some crazy back-end workaround. Yeah, for sure. It's really interesting to me how, like, as I've learned more about how engineering works and how, like, things are made in the real world, I am simultaneously, like, terrified of everything and amazed by everything. Like, the more that I learn about how engineering is done, the less sanguine I am about stuff like bridges, because I know that somebody was designed that bridge under like an incredibly tight deadline and didn't have the resources that they really felt like they needed or the time that they felt like they needed to do the best job that they could. But at the same time, like, we took sand and turned it into the internet, so we did pretty well. Where does someone start being this good this good within 10 years of coding? So just do it a lot, honestly. I mean, I don't claim to be particularly virtuosic. A lot of this is, at this point, the reason it looks like I'm going very fast is because I'm literally just transliterating the documentation. But, yeah, I mean, just do it a lot. And then another thing is not to, like, don't ignore your sense of taste. which sounds super weird and is super weird, but I meet a lot of programmers who just don't have any sense for like what a good design looks like because they have never bothered to like think about that. And a lot of the time, if you have been paying attention, there will be a little alarm bell in your mind that rings and goes, hey, something is bad here. Or like, this abstraction is not good. Or like, you have written the same code 3 times. Probably you should pull that out. There's got to be a better way. And a lot of people just kind of ignore that voice in their head, I feel like, because they are under a deadline, like I said, and they want to get something done. Which is, you know, reasonable, and sometimes that's the right choice, but I feel like you don't become a better programmer if you don't listen to that voice most of the time. Right now I'm interested in SDL. Yeah, SDL is great. A lot of people in the EmuDev Discord use it. I started with a set of YouTube tutorials for 6502, but the guy who was making them stopped halfway through the basics, so now I'm stuck trying to find other good learning resources. Well, there's a lot out there. For the particular flavor that the NES runs, NESDev, the NESDev wiki is probably the best resource that I'm aware of. It's wiki.nesdev.com. That's basically what I'm using for most of this. Invalid instruction 46. Logical shift with the 0 page. Bang, uptime? I don't have a bot. 2 hours and 30 minutes. I looked this up and then I answered you about uptime and now it totally flushed the cache in my brain. Okay, LSR 0 page. I have an LSR. I know I implemented at least one. Oh, there it is. Okay, let's just drop it right here then. LSR DPG is address 46. Wow, you're way over schedule. Lol, my bad. Yeah, for sure. I got rat-holed on a problem and stubbornly refused to stop, basically. Alright, this actually requires a little bit of thinking for a second here. So, we have sure. We're going to need to give it reg names, PCL. And then over here, LSR, sure, ABL. Okay, and then that should just do it, but I need to add the... I'm going to sneeze. I apologize in advance. Oh, this is absolutely incorrect. I can't believe I made it as far as I did with that wrong. Wrongness. I wonder if I just broke everything by fixing that bug. Wait a minute. This is dumb. Hang on. I'm going to undo a bunch of stuff. Just blow this away for a second. I don't know what I was thinking. And before it wasn't really a bug. Yeah, right? But I mean, like, it is. Look at it. Alright, let's just run this, make sure we make it to that 46. 791. Yeah, I don't want to do that. I want to leave it alone. Yeah, 46. Okay, we're good. Okay. What does it mean to do LSR in a 0 page address mode? Read, modify, write instructions. Fetch opcode, fetch address, read from effective address, write the value back to the effective address and do the operation on it. Write the new value to the effective address. Whoa, is that really what that does? All non-act shifts rotates are RMW. Okay. That sounds like a good place to stop, honestly. I don't think I'm going to dive into read, modify, write instructions right this second. I mean, it's not that bad, but I have to write a bunch more opcodes, and I don't want to do that. Or a bunch more micro ops. Also, Silverblaze, I can try to answer any questions that you have. If I can't do it, somebody in the emulation Discord definitely will. Make sure to implement the 2 write cycles. Yeah, is this is the like Battletoadsy thing where it's observable if you don't do that. If you don't do the write back. Nah, not Battletoads. So this only happens, I guess, with like memory mapped registers, because otherwise I don't see how a write back where you literally just read and then write back could have any effect. MMC1 games. Yeah, absolutely. I dropped the link in the chat up above. I could drop it again, I guess, if that would be helpful. Let's learn a little bit about MMC1. MMC1 ignores all consecutive writes. What does that mean? So, like, the second write doesn't count? When the CPU writes to the serial port on consecutive cycles, the MMC1 ignores all write but the first. This happens when the 6502 executes RMW instructions. At least Bill and Ted's Excellent Adventure resets MMC1 by doing inc on a ROM location containing FF. It sees the FF written back and ignores the 0 written on the next cycle. The reason for this is that it has explicit logic. Location of writes is not relevant. Okay. Funky. I literally have the whole chat lamau. Does that mean you've been here the whole time, Pixel? Alright, so that makes sense to me. It's a little bit weird as to why you would do it this way, but makes sense. View botting. Ah. Well, thanks for inflating my view numbers. Okay, I feel like this is a good stopping point. I'm not going to get into the read modify writes today because it requires some more UOPs, and I've been streaming for more than 2.5 hours at this point. I really appreciate everybody stopping by. It means a lot, especially those of you that stuck with me when I was pounding my head against the wall. Oh, come here, buddy. I will give you all a bonus cat before I leave. Come on, Fluffy. Fluffy. Cat. Ah, he left. He's also a good boy. But yes, he's extremely fluffy. Anyway, yeah, thanks a lot. I appreciate it, especially the people who stuck with me through the boring parts. I'll be back tomorrow for, again, probably about 2 hours, maybe a little bit more. And then this weekend, I'll be doing 8 hours at least between the 2 days. So if you've enjoyed yourselves, please come back. If not, thanks for stopping by anyway. Hopefully I'll see you again tomorrow. Bye.